for the introduction. I'm going to present this webinar today where I'm going to discuss some tips and tricks for successfully recording blood pressure with telemetry in rats. As Martin mentioned, I work for Kaha Sciences. I'm the telemetry application specialist, specifically in Europe for Kaha. Martin's already given quite a nice introduction about me, but I joined Kaha in March 2019. So I've been providing sales, training and technical support since then. I've got 4.5 years postdoc experience before I joined Kaha, where I used the Kaha Sciences rat pressure telemetry system. So I've got many hours surgical experience behind me. So hopefully puts me in a position to provide or deliver this webinar with some confidence today. To give a bit of information about Kaha Sciences, we formed in 2017, and as Martin's already mentioned, the company is based down in Auckland in New Zealand. The telemetry technology actually has 15 years of product development behind it. And it was previously under the name, or the company was previously under the names of Telemetry Research and Miller. So this is not necessarily new telemetry technology, but it's been under the umbrella of Kaha Sciences since 2017. Just a little bit of housekeeping for the webinar. So all of the audio for the attendees is muted, so you won't be able to speak to either Martin or myself. If you do want to ask questions, please use the Q&A button at the bottom of the Zoom meeting window and just type these in as you go. And we will get to these at the end of the webinar, and I'll hopefully be able to answer questions that come in. So just to give you a quick outline on what we're going to talk about today. Firstly, for those of you that are unfamiliar with Kaha Sciences and the telemetry systems that we offer, I'm just going to give a really quick introduction to this and the products that we supply and offer. I'm going to then move on to give an overview of the surgical approach for implanting our Kaha Sciences rat pressure telemeters, specifically for arterial blood pressure recording. We'll talk about some of the most common problems that can happen during surgery and then perhaps immediately after surgery as well, when implanting in the abdominal aorta, which is the approach that we recommend. I'll then speak a bit more generally about ensuring the best recovery of your animals post-surgery and why that's important. And then lastly, I will just go over very briefly some unexpected signals that you might see, that you might encounter, particularly, I guess, when you're starting out with this surgery. So why would you be interested in Kaha Sciences for blood pressure telemetry? So to just give you a quick rundown on the hardware that we have. So today I'm specifically talking about our TRM5 series rat telemeters. So an example of one of these is over here on the right hand side of the slide. These telemeters are compatible with our TR181 smart pads. So these are the pads that the home cage sits on when the rat is implanted with the telemeter, and they're the data receivers that collect the data from the telemeter, but they also provide wireless power to the telemeters. I'm going to talk a bit about more about that in the next slide and why that's so powerful and why that's important. The final component of the system that we manufacture is the TR190 configurator system, which is a hardware and software package. One of these is required per laboratory, and it's basically allows for control of the telemetry system, full software control. So it allows you to select one of 40 independent transmission channels for your telemeters and then match that channel, receiving channel for the smart pads. And it also allows you to completely control the telemeters. So you can turn the telemeters on and off using the configurator system without actually having to handle the animals and take them out of the home cage, as well as allowing you to monitor the performance of the system. So that's monitoring the battery level of the telemeter and a variety of other things, as well as providing us with diagnostics files in the unfortunate event that maybe you're having some issues and you need to contact us for support. The final component of a telemetry system more generally is a data acquisition system. And at Kaha Sciences, we don't produce a specific system that fits with our system. Our TR181 smart pads have standard analog output, so BNC cables. So any commercially available data acquisition system that can accept analog output will be compatible with our system. And we're actually able to supply from a number of companies, and we can advise on the best solution for your application. So we can provide support for that as well when you're thinking about investing in a system. So going back to the wireless power, what this means is that the smart pad uses electricity to generate a magnetic wireless power field. This field can pass through non-metallic surfaces, so like the cage base and the animal's skin, and this is completely harmless. And the telemeter has a pickup and inductor coil, which takes this magnetic field and converts it back to electricity. What this means is that the telemeter electronics are powered and the battery that's within the telemeter can be recharged. And this is available when the rat is in the home cage. This is available 24 hours a day, 7 days a week. So you can power your telemeter continuously. So this is really, really useful for long-term recording. If you're interested in disease progression over time or aging studies, you can record from your implanted rats for weeks or months and possibly even up to a year if it was necessary for your experiments. In addition to this, you can record continuously. So if you have an interest in spontaneous activity like sleep, or you're monitoring over circadian rhythms, or you're looking at spontaneous pathophysiological activity, and maybe not from a pressure point of view, but something like a biopotential for EEG and seizures, then you can record continuously to capture far more of these events than you would be able to with other systems. There's no refurbishment required of our telemeters. So what this means is that you don't need to send them back to us between uses for the battery to be replaced. The battery can be recharged by the wireless power field. So there's no real lag time between experiments then. So you can take an explanted telemeter from an animal, clean it, sterilize it, and then put it back in an animal, and that can be done within 24 hours if really necessary. As well as the benefits of the wireless power field, the telemeters do have this built-in battery. And what this allows is data collection away from the smart pad. So up to 5 meters away for between 3 to 6 hours, depending on the model of the telemeter. And what this means is that you can use our system for behavioral studies as well as continuous home cage monitoring. So if you were running your rat in a maze, for instance, or if from a cardiovascular point of view, you're doing exercise studies or something like that, you can do this with our system. And then once you've finished that part of your experiment, you can put the rat back in the home cage and the battery will be recharged by the wireless power of the smart pad. So we actually have 8 rat telemeters, but the 4 that I'm going to talk about today are our pressure telemeters, so our TRM5 series telemeters. And these include our TRM54P single pressure telemeter. So this is the one that I'm most familiar with and have the most experience with implanting. And this would allow you to record a single arterial blood pressure. We also have a dual pressure telemeter, the TRM54PP, that would allow you to record, let's say, arterial blood pressure and left ventricular pressure as well. We have the TRM54PB pressure biopotential telemeter, which would allow you to record arterial blood pressure and ECG. And then finally, we have the TRM56SP pressure sympathetic nerve activity telemeter. And again, you would be able to record arterial blood pressure, as well as most commonly, it's renal sympathetic activity that people look at. Our pressure telemeters come with a standard catheter length of 9 centimeters, which is ideal for arterial blood pressure recording from the descending aorta that I'm going to talk about today. However, if you do have an interest in recording from a different artery, then we offer catheters in customized catheters in lengths of 15 centimeters and 25 centimeters as well. So whether that's for recording from a different artery or a different application entirely, then we offer those lengths of catheter as well. And what's so great about our pressure telemetry system for rats is our incorporation of the Miller microtip pressure sensor. This is a solid state pressure sensor which is located at the catheter tip. It's 2 French on the catheter scale, so 0.6 millimeters in diameter, roughly 5 millimeters long. And what this means is that we offer unrivaled long-term accuracy, fidelity, and reproducibility compared to fluid or gel-filled catheters. With the sensor being right down at the catheter tip, what this means is that we're recording, or with our telemeters, you're recording pressure accurately at source. So you're recording the pressure within the artery. There's no need for a pressure signal to move through the fluid or gel of the catheter into the transducer, which is located in the telemeter body. So this means that there's little signal attenuation over time. There are also no effects of gravity, animal movement, catheter kinking, or clotting that you might see with a fluid or gel-filled catheter. As well as arterial blood pressure, you can record, you can use this system for unique applications as well, including intracranial pressure, ICP, intravesical pressure, which is bladder pressure, compartment pressure, and left ventricular pressure as well. So it's a really, with the incorporation of this solid state sensor, it's a really powerful system. The final benefit of our rat telemetry system that I'm going to plug is the co-housing mode feature that we offer. What this allows is either for you to co-house 2 implanted animals in one cage and record from both animals at the same time. And this is great for the animal's welfare. Rats don't particularly like being singly housed, and behavior is more normal and more natural when they have a cage mate. And we've got customers who are comparing their singly housed data to co-housed data now, and really seeing quite marked differences, and are happy with the co-housing feature. They're actually getting better data from their co-housed animals. As an alternative to housing 2 implanted rats together, you can actually also implant 2 telemeters in one large rat over 350 grams to mix and match between any of the 8 rat telemeters that we offer and measure up to 4 signals. So this allows you to customize your experiments and get unique combinations of parameters recorded from your animals and record the most data that possible from your animal for the most value, to add the most value for that animal and that experiment. So an example of this would be to implant our TRM54P single pressure telemeter and our TR57Y tissue oxygen telemeter, which would allow you to record arterial blood pressure and renal tissue oxygen. Just to give an example of this, the co-housing feature in action, these 2 rats are both implanted with a telemeter. One of them has a 54 pb pressure biopotential telemeter to record arterial blood pressure and ECG, and the other guy has got a single pressure telemeter to record arterial blood pressure. And you can see these rats are housed together in this cage, and we're able to record good data. So just a quick overview of the telemetry system. So we offer the 40 independent transmission channels, so there's no interference between these channels. So you can have a maximum of 40 animals running at any one time. The wireless power is really great for long-term experiments over weeks or months, but also the ability to record continuously allows you to capture more spontaneous data. The Miller microtip pressure sensor offers really high fidelity and highly accurate pressure recordings. There's no need for refurbishment, so as I've already mentioned, you can have a really quick turnaround between experiments. And the co-housing allows you to improve your welfare, or alternatively have unique experiments which really maximize the data that you collect from each of your animals. So that was a really quick introduction to the Kaha Sciences rat telemetry system. If you'd like more information, please go to our website and particularly register for the Knowledge Centre. You do have to register, and then myself or one of my colleagues can authorize your access. But on there, there's a wealth of information, including a load of surgical videos, which I'm going to consistently plug through this webinar, and also previous webinar recordings. And this one that I presented, Telemetry 101, back in March this year, gives a good and more detailed introduction to the Kaha Sciences telemetry system. So this is time to bring Martin back in for the second round of poll questions.
Perfect. Thank you, Phil. Thanks for that great introduction to the Kaha Sciences telemetry system and also the overview of the way the systems are configured. Okay, so I'm going to run another quick poll and we'll let you continue on with your presentation. There are 2 questions for this poll as well. So if you could once again kindly just respond to these. Question number 1, we'd like to know which parameters, plural if necessary, from a telemetry implant would be of interest to you. So there are the biopotential signals up at the top, ECG, EEG, and EMG. Blood pressure, which is what we're talking about today, sympathetic nerve activity, tissue oxygen, temperature, activity, are all options. There's also an option for optogenetic stimulation for those of you that might be interested in that. We can certainly answer questions about that if you have any. Feel free to enter any questions into the Q&A, a reminder there. And then finally, would you be interested in learning more about a chronic implant for recording blood pressure in rats, what we're talking about today? So if you would, just indicate so. And if not, that's fine too. Okay, we'll just give you another moment. We have about 70% of our audience voted. So Phil, just because I know you are online, as an FYI, all of our audience members here today are interested in blood pressure, so they've come to the right event.
That's good.
Okay, very good. Okay, I think I'll end the poll there. So Phil, I'll let you continue on whenever you're ready. Thanks.
Great. Thanks, Martin. Okay, here we go. So the next part of the webinar, I'm going to talk more now about the surgical approach for blood pressure recording with our telemetry system. So just before I go into more detail, I'm going to give you some tips that I think are important before you start out. Firstly, practice is really, really important. Practice is actually very difficult here in the UK with the regulations that we work under. So when I was starting out using the system, I would actually use older, say, ex-breeding animals or something like that that had run out of their use, and I would euthanize them and actually practice on dead animals. And what this allowed me to do was really improve my fine motor skills, get used to working under a surgical microscope, and just while cannulating a dead artery is not kind of indicative of real life, it allowed me to work through the process and understand the different steps of the process, and really understand how to carry out the surgery. So if you are able to practice, I would really encourage you to do that, and particularly before you start thinking about waking animals up. Preparation is also absolutely key. This is quite a tricky surgery, and there is a period of it which is very time critical as well. So thinking about the equipment that you need, how you're going to have it laid out on the bench around you, and having everything that you need at the beginning of surgery, and often more, particularly with disposable items, having more than you would ever actually need for each surgery is really important. So I always recommend people having a checklist so that they can work through and make sure they have everything laid out in front of them. And it's a luxury that some people can't afford, and I certainly wasn't able to have this when I was doing the surgery, but having an assistant present, if there's somebody in your lab that can help you and just be present while you're doing surgery to fetch you things if you need them, is actually a really useful thing to have. As I've already mentioned, the Miller microtip pressure sensor, which is located down here at the catheter tip, it provides really great pressure measurements, but it is more sensitive than a fluid-filled catheter. So we really recommend that when you're handling it, you avoid handling the 5 millimeter area right at the tip as much as possible. and don't go anywhere near it with forceps if possible, particularly this white window area, which is actually where the pressure is detected. We recommend the use of forceps padded with silicone tubing, and that you only handle the wire area of the catheter. Finally, please seek advice. If you're using our system, as I've already said, register for the Knowledge Centre. There are loads of surgical videos. There's loads of information there, particularly regarding the blood pressure telemeters and implantation. So please look at those, and also email us. Myself and my colleague Sarah Jane have a wealth of experience in implanting blood pressure telemeters. So we have seen most things between us and can answer most questions. So with our blood pressure telemeters, we recommend recording from the abdominal aorta. And the reason for this is firstly that the telemeter body is optimally placed in the abdominal cavity, the peritoneal cavity, to receive wireless power from the smart pad. So you're already opening up the abdominal cavity. So by implanting in the abdominal aorta, it means that you'll need to make fewer skin incisions. So you've already opened up the abdomen. You may as well implant in the descending aorta. Descending aorta is also a nice, plump, large, relatively large artery that you'll be able to isolate and see really easily. So it's a good target. So there are fewer skin incisions, and also there's because you don't have to open up other parts of the animal to get to a different artery. And then because of that, there's no need for subcutaneous tunnelling of the catheter, which raises the possibility of damaging the pressure catheter. So best avoided if possible. I'm not going to go into too much detail about the surgery itself. There are, as I'm going to say, and I'm going to say it several times, the Knowledge Centre has the surgical videos that you can watch. So they will be more valuable than me describing in great detail the different processes in the webinar. But very briefly, you want to isolate a stretch of the descending aorta between the renal, the branch for the renal arteries and the iliac bifurcation. And you roughly want to isolate a 1 centimeter stretch of the aorta and insert suture threads underneath the aorta just beneath the renal arteries and just above the iliac bifurcation. When you've got your suture threads in place, you can then occlude the artery, and using a bent 23 gauge needle, make a small hole in the artery. And then you use the 23 gauge needle as your catheter introducer as well. So you can push the catheter into the lumen of the artery, approximately 1 centimeter to 1.5 centimeters into the artery. However, you want the tip of the sensor to be below the level of the renal artery. Once your catheter is in place, you seal the hole with low viscosity tissue adhesive. I'll talk a bit more detail about that later. And then finally, you use a surgical mesh patch to support the catheter and actually hold the catheter in place, so that the sealing of the hole is not going to hold the catheter there forever. It's this mesh that really provides the mechanical support to stop the catheter pulling out. So it is quite a tricky surgery, particularly for those people that don't have a huge amount of surgical experience beforehand. And I'm just going to talk through some common complications that can occur, firstly, during surgery. So if your anatomy is not great, I'll tell you that the vena cava, which is vein, runs very close to, and to look at it, it's effectively connected to the aorta in the abdomen. So the vein has a very thin wall, and it's perfectly possible to puncture the vena cava during isolation of the aorta. We recommend that using a surgical microscope is an absolute essential for this surgery. At the very minimum, 10 times magnification. I certainly used to use 20 to 25 times magnification whenever I was doing this surgery. And that will really help you to see exactly where the tips of your forceps are at all times, so that you can keep them away from the thin wall of the vena cava. It's just vitally important to work with as much care as possible around the vena cava. There's no correct way to set up and carry out this surgery. From the surgical videos on the Knowledge Centre, you'll see that my colleague Sarah Jane orientates the animal with the head to her left-hand side. And then she's able to use her forceps and always keep the points of the forceps towards the thicker wall of the aorta. I, by contrast, used to use blunt forceps to dissect underneath the aorta and would have the animal orientated with its head away from me. It really is a case of practicing to see what works for you, and you will find a technique that works best for you as well. Secondly, there can be some hidden side branches coming off the aorta. So these can be beneath the aorta, and unfortunately there's not much you can do about those because you've got no idea where they're located. However, if you can see them to one side or the other of the aorta, it's really important that you occlude these with suture material as well. Otherwise, you'll get continuous backflow from these side branches into the aorta. It will make gluing and sealing the hole in the aorta very difficult. So you can see that here that Sarah Jane during this surgery has isolated this side branch that's coming off the aorta. So moving on to the most common complication after surgery is hind limb lameness. So what I mean by this is reduced movement in the hind legs and often accompanied by pale feet as well. And this can be caused by two things. Firstly, nerve injury, which can be caused during dissection of the aorta. So either you can damage, there's quite a large amount of nerves that run down the aorta and the vena cava. So you can damage this with your forceps when you're dissecting out the aorta. You can also damage it with the suture material if you're not careful. And it's possible to irritate it with the glue as well, the tissue adhesive, if you apply too much tissue adhesive. I guess this is the solution to this is practice again, that after a while you will get a feeling for where the nerves tend to be in the animals that you're using, and you'll be able to avoid them as much as possible. The second and most likely cause is tissue ischemia. So this is reduced blood flow to the hind limbs after surgery. And there are two main causes of this. So firstly, you have to occlude blood flow to the hind limbs in order to insert a catheter. So prolonged restriction of blood flow in this part of the surgery can cause reduced blood flow to the hind limbs. So we say that when you're occluding the aorta, you should aim to keep this to a maximum of 10 minutes. And in order to do this, it goes back to the point I made earlier that preparation is absolutely key. Make sure that you have all of the equipment that you need laid out in front of you and very easy to reach. And what you don't want to do is get to this stage in the surgery and realize that your telemeter is still in its sterilizing solution, for instance, and needs to go through 5 minutes of rinsing. And you can very easily prepare for the surgery. So my colleague Sarah Jane uses these sharpened swab sticks to apply the tissue adhesive. So you can prepare those before surgery. You can make sure that your forceps padded with silicone tubing. They're ready to go, that you've got the silicone tubing on the forceps before you occlude the artery, and that you've prepared your 23 gauge needle with its 45-degree bend for introducing the catheter to the aorta. It's really simple. Just make sure that everything is well prepared before the surgery. A second cause of tissue ischemia can be using and applying too much glue to seal the artery. So we recommend using this low viscosity tissue adhesive, either the histoacryl from Braun or the Vetbond from 3M. And these two tissue adhesives are really good, and they do provide a really nice seal. However, because it's low viscosity, if you're not careful with it, it will go everywhere. So the first point to to make is to go back to something that I said earlier about occlude any side branches that you can see. If there are side branches that are going to cause a leak back into the aorta, you must make sure that they are occluded. This will really help with gluing up. And then on the left-hand side, once you're ready to start gluing and sealing that hole, you can see on the left-hand side that we've got an example of a good amount of glue. And you can barely see actually that there's any glue has been applied, but you can see that the suture thread has been relaxed on the left-hand side of the image, and that the artery has plumped up and flow has returned to the artery. On the right-hand side, you can see that really that there is too much glue here. The glue has leaked down the side of the aorta. And if you think that when you have the artery occluded, when you've inserted the catheter and you're gluing up, if the glue is able to leak down, it can constrict the aorta and maintain that occlusion even after you've removed your suture thread. So what I really recommend is applying as little glue as possible. If you do end up with a situation like this where you've accidentally applied a really big drop of glue, or you're having to apply lots of glue because you can't stop a leak, that it's worth just removing the excess glue, thinking about that 10-minute time period that I mentioned before, but it is worth taking a little bit more time to make sure that you're not applying too much glue and you're getting a good seal. Again, I'm going to say it, there's more information on the Knowledge Centre. The surgical videos provide a lot of information about this. Finally, once you've finished your surgery, you can actually, there are a few visual checks that you can do to make sure that blood flow has returned. So before suturing, you can check, visually check the blood flow in the aorta and the iliac arteries. Once you remove that suture occlusion, you should see the artery plump up and begin pulsing again, and also below the point where the catheter is inserted as well. You can check for leaks before suturing. You're now out of the time pressure phase of the surgery, so you can leave the animal for 1 or 2 minutes just before you close up, just to see if there's any obvious sign of the blood leak. And then once you have closed up, just before you remove the anesthesia, you can check the hind limb color and temperature of the limbs before you recover the animal. As a side point, it's really important that throughout surgery, the animal is kept warm, and also when it's recovering immediately afterwards as well. So this can be achieved with a heating pad or a homeothermic blanket. And I know that Synteca do have some options for this available, so please check those out on their website. Okay, so that was a discussion about the tips and tricks for actually proceeding with the surgery and how to overcome some complications that you might encounter if you're embarking on that surgery. So what I'm going to do now is move on to talk a bit more generally about surgical recovery. As a general rule, good surgical practice leads to successful outcomes, and the data that you'll collect from your animals will be of the highest value to you. So we would always recommend that you use a gaseous anesthetic for any telemetry surgery, not just the blood pressure surgery. So this is isoflurane as an example. What the gaseous anesthetics do is they provide a much more stable plane of anesthesia, and the animals also recover much better and much more quickly from a gaseous anesthetic than they do with the injectables. We really emphasize the need for aseptic technique, and again, the surgical videos on the Knowledge Centre, Sarah Jane has got excellent aseptic technique, and you'll be able to see that for yourself. And this really helps to minimize the risk of infection post-surgery and improve the recovery of your animals. It's a very major surgery for the rats. Any telemetry implantation, let alone the blood pressure telemeters, where you're going into the abdominal cavity. So we recommend that you provide analgesia for your animals, whether that's an opioid-based analgesic or an anti-inflammatory, or both. You can talk to your local veterinarian about this. And we also recommend providing prophylactic antibiotics. You shouldn't necessarily need them because of your aseptic technique, but if you do provide prophylactic antibiotics for just a few days post-surgery, this just ensures that there's minimal risk of infection. When you're closing your wounds, and particularly the skin incision, it's worth thinking about how you want to do this. So because you're closing up the abdomen, this is very accessible for the rat. So if you use an externalized suture, then they're going to be able to play with them, chew them, and possibly open themselves up again after surgery, which is not good for the rat, and it's also potentially not good for the telemeter if the rat's able to access the telemeter. And it has happened in the past where rats have taken telemeters out themselves. So when I was doing the surgery, I would use a particular suture pattern called a running subcuticular, which internalizes all of the sutures, so there's nothing for the rats to play with. I know that some people do use clips, but I was always reluctant to do this with the skin incision because, again, while the rats might not be able to take the clips out themselves, it's something to play with. And if they're able to play with them and pull on them, then this may be a source of irritation and might slow the wound healing process. And finally, in the day or immediately after surgery and in the days preceding surgery, it's important to give your animals fluids. So whether that's electrolyte jellies in the cage or subcutaneous injections of saline. You can provide follow-up dosing of your analgesics and your antibiotics if needs be. And I always used to give my rats some treats, so something like a breakfast cereal or maybe chocolate biscuit if I was feeling generous, or some of a chocolate biscuit. And what this helps to do is to encourage the rats to start eating after surgery and start gaining weight again. There will be a period of weight loss, and you don't want that to go on for too long. And just to emphasize the impact of surgery on the animals, the animal's physiology and the parameters that you're interested in recording may well be affected in the days immediately preceding surgery. So here you can see that circadian rhythm is interrupted for 6 to 7 days post-surgery with a reduction in heart rate and elevated blood pressure. And it really takes maybe 7 days for this cycling to come back into normal. This isn't arterial blood pressure data, but this is some interesting data from one of our users at the Danish Headache Centre in Copenhagen. They published this great paper in June of this year, but they showed that their intracranial pressure signal takes approximately 9 days for it to form a stable baseline. So they don't even begin thinking about taking baseline data or any experimental interventions until their 9-day recovery period has elapsed. So just to give you an example of this, we would recommend that you give your rats at least a week, 7 days post-surgery. So this allows the behavior and physiology of your animals to normalize. If the telemeter in the animal needs to equilibrate at all, then this can occur during this time. Wound healing can occur. If you do need to provide prophylactic analgesics and antibiotics, you can give these for a few days post-surgery, but then also allow your animals some time to recover from this as well. After that, your experimental periods, your baseline recording and your experimental interventions can begin. And what's important to remember that with our telemetry system, you don't have this restriction of battery life, and because of our use of innovative wireless power. So you don't really need to worry about how long it takes for your animals to recover. You're not draining the battery of a telemeter, you're not reducing the amount of experimental time you've got. So your experiments can continue for weeks or months without a concern about the data that you'll collect from the animals eventually at the end of the recovery. So the last thing I'm going to talk about is troubleshooting some unexpected signals. I'm not going to spend a huge amount of time on this. We always recommend that you contact us if you've got problems and you're seeing unexpected signals. But the most common with the blood pressure surgery would be where the pressure catheter has pulled out of the aorta. This is usually represented as a flat line pressure between 0 and 20 millimeters of mercury, which reflects the pressure within the abdominal cavity. You'll see sharp fluctuations in the pressure waveform, which coincide with the animal moving around, and you may also see a respiratory rhythm present as well. So this means that the catheter has pulled out from the aorta. And there are a couple of solutions to this. Review surgical procedure, which I'll just talk a little bit more about in a couple of slides' time. And also thinking about how you're handling your animals, particularly immediately post-surgery. So it's really important to handle your animals with care, and really emphasize that you mustn't ever pick them up by the tail. The telemeter is during the wound healing process, the telemeter or the connective tissue will be growing through the surgical mesh that we recommend that you use to hold the catheter in place. So any disruption of the telemeter and the catheter in the healing time may cause the catheter to pull out. And the most common time for this to happen is probably up to about 10 days after surgery. Alternatively, you might see a slightly different signal, which is indicative of the catheter has actually become loose and it hasn't pulled completely out of the artery yet, but it's moving around within the aorta. And in this case, in these two examples on the right-hand side, you'll see a small or variable pulse pressure of probably usually less than 10 millimeters of mercury. Your mean arterial blood pressure will be lower than expected and also quite variable, which is as the animal moves around and the catheter moves around in the aorta. And you may see some sharp fluctuations in the pressure waveform as well. So again, the catheter is moving around, and the cause of this is likely to be the same as the previous slide. So you'll need to review your surgical procedure, which I'll come on to next, and think about how you're handling your animals. Just handle them with care, handle them gently. So how would you, what do I mean by reviewing your surgical procedure? So this really means the proper use of the surgical mesh. So as I mentioned previously, this seal in the artery is not going to hold the catheter in place forever. You need to use the surgical mesh, and you need to make sure this is well connected, well glued to the connective tissue at either side of the aorta, but that you also have a good connection between the mesh itself and the catheter using glue. Sometimes this can be a bit tricky to achieve. The tissue adhesive doesn't necessarily glue the plastic to the silicone very well, but we find that if you just apply a small amount of saline, a small amount of fluid, this will help. So here you can see an image from a surgery where you can see the mesh is glued on either side to the connective tissue, and also that there's some glue holding the mesh to the catheter as well. So those aren't the only unexpected signals that you might see. Those are the most common for the blood pressure surgery. There are some others that you might come across, and what we recommend is that if you do see anything that you're not sure about, contact support at kahasciences.com, and we will be able to help to advise on the best solution to this. Okay, so just to summarize, I've given an introduction to the Kaha Sciences RAP telemetry system and pressure telemetry, discussed the advantages of implanting in the abdominal aorta, talked about some of the complications that can occur with surgery, how to ensure good recovery of your animals and collect the best data possible from your animals. And then finally, just a little bit about troubleshooting unexpected signals. So one final plug for the Knowledge Centre. Please go there and register to view the material that's available there. Surgery videos, previous webinars. If you have any questions about pricing, the two email addresses are there for Kaha and Syntica. And then specific scientific inquiries or technical support at kahasciences.com. So thank you very much for listening, and now I'll take any questions.
All right, Phil, thank you so much for that. We appreciate it. And let's dive right into our Q&A. I also can't stress enough, I know you've done this a few times during your presentation, but the Knowledge Center has fantastic resources and particularly the surgical videos are really impressive. And that's something that we really didn't go through in detail today. So I would encourage everyone to register for the Knowledge Center if you want to gain access to those surgical videos. Okay, so we have some great questions. We're going to try and get to as many as we can. Phil, some questions came in before the session, so let's start with those.
Yep.
You show waveforms from catheters that have been dislodged from the aorta. Do the animals die when this happens, or what's your experience with that?
Yeah, I mean, I agree with the question that it seems counterintuitive that the rats don't just die when this happens, but we see consistently that it really isn't common for the rats to die in this case, and we can only think that the aorta must constrict very quickly and a clot forms to prevent blood loss when the catheter pulls out of the aorta. Because even if you notice this relatively quickly, that after it's happened, a few hours after it's happened, and because the animal is no use to you, then if you're only interested in blood pressure, so you can explant the telemeter, and you very rarely see any large blood clot in the abdomen after this. So no, basically
Okay.
the rats can be perfectly happy and healthy after this has happened.
Perfect. Can you use a pipette tip to apply glue, and do you have a preference for the type of glue? You mentioned Vet Bond and another product from Braun as well.
Yeah, sure. So yeah, you can certainly use a pipette tip. That's how I used to apply glue, and found that I got good results using a pipette tip. Usually a 20 microliter pipette tip was good for this. My colleague Sarah Jane doesn't like using pipette tips. She much prefers the sharpened swab stick, and she feels that she has more control over the amount of glue that she applies with this, but it really is up to the individual. With regards to a preference, I've used both histoacryl and Vet Bond. I would say maybe you get slightly better results with the histoacryl. It certainly comes in smaller volumes, so perhaps if there's a bit of a gap between surgeries, it doesn't. You can't allow it to go off like you can with the Vet Bond, but you can certainly get good results with both. It's not
Perfect. Okay. I'm going to bounce around a little bit. Dr. Engard has asked if the system will work while away from the charging platform. So you touched on this a little bit. And the example she provides is, for example, moving the animal to a metabolic cage. Is this possible?
Yeah, so it's perfectly possible. The transmission range of the telemeters to the smart pads is 5 meters. It depends how long you can do this for, depends on the telemeter model. So the pressure telemeters, I think you would be able to do this for about 4 hours before you needed to put the animal back in its home cage to charge the telemeter battery again. So it's possible, but if it just depends on how much time you'd be wanting to do it for.
Perfect. Okay. You talked about maintaining temperature post-surgery. Can you comment on what temperature the animal should be maintained at?
Yeah, so I used to just use I can't think of a good description of them. They're basically heat mats that you would use for babies, I guess. That have they don't go up particularly high temperature wise, and I just used to place the cage kind of half on one of those pads and half off, so the rat had the option, if it needed or felt that it wanted to be warm, then it could sit on the warm patch, or it had another part of its cage where it could go if it was getting too warm. So
okay. And how long would you do that post-surgery?
From personal experience, I used to give them maybe between 4 and 6 hours in a recovery room before I moved them back into the room where the experiments carried on, where the smart pads were. It's kind of up to you, really.
Okay.
Just a few hours, just to give the effect of the anesthetic to wear off and get them eating and drinking again as quickly as possible.
Okay. Perfect. So that question was from Delphine, and she actually has another question. So you talked about the recovery time, say 6 to 9 days following surgery, but how long, following the recovery, I suppose, can one maintain reliable recordings in rats? I mean, to paraphrase then, how long can these chronic experiments go for?
Yeah, sure. So I would run the actual experimental phase. I would have running for about 6 weeks. I know that my colleague Sarah Jane in New Zealand has had, I think they've had them implanted for up to a year. Certainly months is not, 6 months is not uncommon for people to get, but I think they've had them implanted up to a year and collected data for a year as well. So.
Wow. Okay. So a very long time.
Yeah.
Okay. I'm just going to go back to some of the previously asked questions. Roughly what size of mesh patch do you recommend?
Roughly 5 mm square would be plenty. I wouldn't, talking about preparation, I wouldn't cut that until I actually needed it. I'd have a larger mesh patch or a mesh area of mesh that I'd sterilized pre-surgery, and then I would cut it as I needed it. But yeah,
Okay.
5 mm square.
Perfect. Is it possible to implant the telemeter in other arteries? You talked about the abdominal aorta today specifically, but what are your thoughts for other arteries?
Yeah, I mean, it's perfectly possible. You have to consider the diameter of the artery and the diameter of the catheter. So anything, any artery that's particularly small might be tricky. But I mean, I know that people have implanted them in the femoral, for instance, and the carotid. It's just a case that we recommend the abdominal aorta because of where you're placing the telemeter body anyway. But if you've got an experimental need to record from a different artery, then certainly it's possible, and you could follow a very similar protocol, I think, for that as well.
Perfect. I'm conscious of the time, so we'll just maybe ask a couple more questions. Can you comment on cleaning protocols and reuse of these telemeters? So how do you clean them, and can they be reused?
Sure. Yeah. So reuse is encouraged with our telemeters. There's again on the Knowledge Centre, there's a very detailed description and instructions for cleaning specifically the pressure telemeters. But just briefly, you explant them from the animal and put them straight into cleaning, enzymatic cleaner. So we recommend Tergizyme. You leave that for about 15 minutes before taking it out, and then you can manually, using a microscope, clean off any connective tissue that might be remaining. Using soft gauze, you can clean the sensor tip as well. And then you can rinse in water, distilled water or saline, and then it's ready for sterilizing. People use cold sterilants like glutaraldehyde, but also we recommend ethylene oxide sterilization if you have that capability. That's the best.
Perfect. Okay. We have a handful of questions here from one of our current users in Japan. So Dr. Fujita, what I would recommend is that we would get back to you afterwards to answer those. Phil, just knowing that we've come to the end of the 60 minutes, looking at the questions remaining, are there any that you feel we should quickly answer now, or should we tackle these all after the fact with the individual participant?
I will just say that no, we don't have a system for recording pressure in mice at the moment. Our mouse telemetry system is biopotential recording only, so ECG, for instance. I think that covers a couple of questions. The other one is do we provide dummy transmitters? No, we don't. That's something that I think perhaps we do need to look into, though. That's providing. So, thank you. That's a good suggestion.
Mm-hmm. Is there an alternative to a dummy transmitter, but rather, if one wants to practice just the arterial insertion, is there an alternative to the catheter? Or there,
just to progress and to practice the surgery, if you have a means of recording acute blood pressure, say with a in an anesthetized animal, then I would use a fluid-filled catheter just to practice the surgery.
Okay.
That would, if you've got set up to do that in your lab, then that's as good a practice as you'll get. I did a lot of femoral cannulations before I moved on to this. So.
Right. Okay. Fantastic. That's good advice. Okay. Well, thanks for that. So we've reached the end of our session, and to be respectful of everyone's time, I think we should wrap things up. So we will answer any outstanding questions privately. We will also provide a transcript, a written transcript of this Q&A. Look out for an email from us with access to the recording for today's session and slides. Phil, thank you very much for your excellent talk. We've got some great feedback from people for you, thanking you as well.
Right.
And as Phil mentions, reach out to us if you have any questions, and we'd be more than happy to answer them for you. So thanks again to all of you for taking time out of your day to attend our session, our webinar, and we look forward to seeing you again at one of our upcoming events. Have a good day.
Thanks, Martin.
Thank you.